Good morning, one and all. Good morning to one and all. This is Sethi Meenakshi, Assistant Professor of Mathematics from Fatima College, Madurai. Today we are going to see how to find the optimum solution of the given linear programming problem using graphical method. Let's see about it. So the other name for graphical method is search approach method. And when we can able to find out the optimum solution using graphical method. If the given LPP has only two decision variables, we can able to solve using graphical method. That is given in first point. Second point is the first step is to find out the feasible region. And what is the feasible region? It is the intersection of all the regions represented by the constraints, and it should be restricted to the first quadrant. And the third point is we have to find out the value of the objective function at each corner points of the feasible region. And at last we have to select the point which optimizes the value of the objective function. Let's see about it briefly while doing the problem. So these are the special cases of linear programming problem. First one is alternative optima. Optimum value. What is meant by optimum value or optimum solution? We can get more solution, and the best among many solution is the optimum solution. Alternative optima means we can get the optimum value at more than one point. That is alternative optima. Let's see the definition. When the objective function is parallel to the constraint, the objective function will assume the same optimum value at more than one point. That is why we can call this as alternative optima. Second one is unbounded solution. When the values of the decision variables if increased indefinitely, we can call that feasible region as unbounded. And third one is infeasible solution. We will get a solution, but we'll get it at a infeasible region, which means not restricted to first constraint. That is infeasible solution. When the constraints are not satisfied simultaneously, then the LPP has no feasible region. Let's say about the problem. Solve the following LPP using graphical method. The objective function is minimize z equal to 20x1 plus 40x2 subject to the constraints. Here three constraints has been given, so that we have to draw a three lines. So 36x1 plus 6x2 greater than or equal to 108. 3x1 plus 12x2 greater than or equal to 36. 20x1 plus 10x2 greater than or equal to 100. And the non-negative restriction is x1, x2 greater than or equal to 0. Here they have given two decision variables x1 and x2. So we can able to solve using graphical method, right? So what is the first step? We have to find out the lines to be drawn in the graph. For that we have to consider only the constraint, right? So whatever inequalities it will be, we have to consider it as equation, okay, equal sign, and we have to find out the point, right? First point, first we have to plot these lines in a diagram, right? So for that we have to find out the points at which these lines intersect. So for that I have taken the first constraint. What is the first constraint? 36x1 plus 6x2 greater than or equal to 108. So consider this inequality as equal and find out these values. How to find out these values? Put x1 equal to 0 and find out the value of x2. That is 0, 18. And in the next step, x2 is equal to 0 and find out the value of x1. That is 3, 0. Likewise, we have to find out for the second constraint. What is the second constraint? 3x1 plus 12x2 greater than or equal to 36. Consider it as an equal sign and find out the points. How to find out? First put x1 equal to 0 and find out the value of x2. And second thing, x2 is equal to 0 and find out the value of x1. that is 0, 3 and 12, 0. In the same way, find out for the third constraint also. So 0, 10 and 5, 0. Next, we are going to plot these points in a graph, right? So here I consider one as, this is the points we are going to draw for first constraint. This is for second constraint and this is for third constraint. So see all the numbers. So we have drawn two axes, x1 and x2, right? And I have marked as 2, 4, 6, 8, 12, 3, 6, 9, 12, 15, 18, etc. Now we are going to plot these points 0, 18. Where is 0, 18? 0, 18. X-axis 0 and y-axis 18. So this is the point 0, 18 and 3, 0 is here. And draw a line for this. That is the line represented the first constraint. In the same way, we are going to draw the second constraint 0, 3. X0 and y3 means this point. Second one is 12, 0. X-axis 12, y-axis 0 means this point. So draw a line. So this line represents the second constraint. Right? The same way. Third constraint 0, 10. X-axis 0 and y-axis 10 means this point. Right? This point. And 5, 0 means this point. So draw the lines. And this line represented the third constraint. This line represented the third constraint. Right? So next we are going to find out the intersection of all the points. First we have to find out the shaded region for each constraint. They all given in greater than or equal to sign, right? So greater than or equal to sign, which means if it is less than or equal to, directly we can say that that is the region which is near to the origin. If it is greater than or equal to means the region should be away from the origin. Okay. So if you find out the region for each constraint, the intersection point will be like this. So the first step is we have to find out the feasible region, which is the intersection of all the points restricted to first constraint. Next mark the corner points. So we got 4 corner points. What are they? A, B, C and D. A and D we can find out directly because it lies on the x-axis and one lie on the y-axis. So directly we can able to find out the value of A and D. Next, how to find the value of B? Say the point B where it is the intersection of which two constraints. If we solve the two constraints, we can find the value of B. In the same way, C is the intersection of second and third constraint. So if we solve the second and third constraint, we can find the value of C. Okay. So our next aim is to find the corner points A, B and C. Okay. We'll see it in the next step. So here the feasible region is unbounded. So this is the feasible region, right? So we cannot find when we will get whether it is closed or not. Here the feasible region is unbounded. Okay, இதோட feasible region வந்து unbounded இருக்கு. ஸோ இதோட சொல்யூஷன் வந்து போய்கிட்டே இருக்கும். இதோட ஃபைனல் சொல்யூஷன் எங்கே கிடைக்கும்ன்றது எனக்கு தெரியாது. ஸோ feasible region கேட்டாங்கன்னா தட் இஸ் unbounded. இந்த ரீஜியனில் சப்போஸ் மினிமம் வேல்யூ இதோட மினிமம் வேல்யூ எங்கே இருக்குன்னு கேட்டாங்கன்னா we can able to find out. ஸோ இந்த கார்னர் பாயிண்ட்ஸில் எது மினிமமோ தட் இஸ் த ஆப்டிமம் சொல்யூஷன். சப்போஸ் இதோட வேல்யூக்கு இந்த அன்பவுண்டட் ஃபீஸிபிள் ரீஜனுக்கு மேக்ஸிமம் வேல்யூ கேட்டாங்கன்னா ஓகே இட் இஸ் இன்க்ரீஸ்டு இன்டெஃபினெட்லி போய்கிட்டே இருக்கு, அதோட மேக்ஸிமம் வேல்யூ என்னால் கண்டுபிடிக்க முடியாது. ஸோ இந்த ப்ராப்ளம்க்கு அப்ஜெக்டிவ் ஃபங்க்ஷன் மினிமம்னு கேட்டாங்கன்னா ஐ கேன் ஏபிள் டு ஃபைண்ட் அவுட். அதுவே மேக்ஸிமம் கேட்டாங்கன்னா தட் இஸ் அன்பவுண்டட் சொல்யூஷன். லெட்ஸ் see it in the next step. எப்படி கண்டுபிடிக்கணும்? how to find B. So it is the intersection of two constraints. So in the rendu constraint intersect agudho adu rendaiyum solve pannona we will get the value of b. The same way we will get the value of c. So what are the corner points? A, B, C and D. And what is my objective function? 20x1 plus 40x2. So in the place of an x1 and x2 we have to find out the value of this 720, 280, 160 and 240. Here the objective function is minimize z. So இதே problemல maximize னு கேட்டாங்கன்னா that is unbounded solution, right? But here they have feasible region unbounded, right? Optimum solution minimum கேட்டாங்கன்னா இதுல எது minimum that is the optimum solution. Optimum solution maximum கேட்டாங்கன்னா that is unbounded, right? So here the optimum solution is, so இதுல among all the corner point the minimum value is 160. Where will you get? At the point C, 4, 2. So the optimum solution is minimize z equal to 160 at x1 equal to 4 and x2 is equal to 2. Right? Thank you.